Alright, so this is page 25. So we are graphing this rational expression. So remember, whenever we graph, the first step we should always, if there are things to be factored, you should always factor this out. So this can be rewritten as, please factor this and please factor this. The factors of this are x plus 5 and x minus 2, and the factors of the denominator is x plus 5 and x plus 3. I can simplify this. I see that x plus 5 and x plus 5 can be cancelled, but before I do that, I would like to write the restriction, basically the domain, because the domain comes from the restriction. So basically my restrictions are x cannot be, so its domain is always all real numbers except the restriction. So my restriction is x cannot be equal to, from plus 5 I get negative 3, and from positive 3 I get negative 3. So those are my restrictions, so therefore that affects the domain. Now I can cancel this out and I am simplified to, my equation is either r of x or y, doesn't matter, x minus 2 over x plus 3. This is my simplified equation after I cancel out the common factors. Let's come back to x-intercept and y-intercept later. Let's just start with the values of discontinuity. So I've already said my discontinuity is at x equals to negative 5 and x equals to negative 3, but it tells you to write the type of discontinuity. So the factor that's got cancelled, that is your removable. So x equals to negative 5 is the removable discontinuity, and x equals to negative 3 is the non-removable discontinuity. And what does that mean? How does it get transferred to vertical asymptote and whole? So the one that is non-removable, the one that is removable, it's a whole, but that's one that's non-removable is the asymptote. And asymptote is a vertical line. It's a vertical line, and vertical line, the equation of vertical line is always just x equals to negative 3. So you just write down that as it is, because it's an equation of a line. Whereas a whole is a whole, literally it's a coordinate point which needs an x and a y, right? So I know my x value for the whole because removable discontinuity is a whole. So the value of x is negative 5, but how do you solve for y? So if I'm given an x, I can always solve for my y using this equation. Please do not use this equation. Do not use the original equation. Like I've said in the class, there are enough errors where they try to substitute here. What happens when you try to substitute here? Negative 5 plus 5 will give you 0. You will always get a 0 when you substitute the original equation, which contains the opposite of this. So you want to put it here. So this one is x equals to negative 5. So negative 5 minus 2, negative 5 plus 3. So that is negative 7 over negative 2. So that is positive 7 over 2. Just simplify this. Negative 7 over negative 2, which will give you positive 7 over 2. Okay, horizontal asymptote. So remember what I spoke about the horizontal asymptote? You take the first term over the first term. So your horizontal asymptote, the easiest way is to look at this, first term over first term. What does this simplifies to? X square over x square is 1. So y equals to 1. So that's your horizontal asymptote. If you have horizontal asymptote, there is no slant asymptote. Okay, so we've got this far. We have most of the information. We just need a couple, the x-intercept and the y-intercept. So remember, whenever you're solving the x-intercept, algebraically, doesn't matter which function, you set y to be equal to 0. So let's look at our equation. This equation, y, so you're setting y to be 0. 0 equals x minus 2 over x plus 3. And you're basically solving for x here, so you can either cross multiply or multiply both sides by x plus 3. There are different ways to do it. So if I multiply both sides by x plus 3, that's one way to solve it, because you want to get rid of the denominator. What you do to the left side, you do to the right side. This x plus 3 gets cancelled, and you're left with 0 times x plus 3 is 0 equals, these two are cancelled, so x minus 2, therefore x equals to 2. Therefore you can't leave it like that. When you write an intercept, you always have to write it as x, the value of x is 2, but my y is 0. You always have to write it as a coordinate. So please keep that in mind. You want to write it as a coordinate. You want to write it as a coordinate. Now I'll do y-intercept. And whenever you solve for the y-intercept, which is on the y-axis, x is always set to be 0. So go back here. So you want to solve for y. 0 minus 2, 0 plus 3, which is negative 2 over 3, but when you write it as a y-intercept, it is 0, negative 2 over 3. 0, sorry, here we go, let's move the paper, 0, negative 2 over 3. I know it's a lot of scribbling, but hopefully you can see it. Okay, alright. I have all the information, I'm ready to graph now. So let's draw both the asymptotes. My vertical asymptote is at negative 3. 1, 2, 3. My whole is at negative 5, 7 over 2. So this is negative 3. So negative 5 will be somewhere here. And 7 over 2 is the same as 3.5, right? 7 by 2 is 3.5. So 1, 2, 3, somewhere here will be my whole. We are approximating because we don't have the exact graph thing. And then horizontal asymptote at x equals to, y equals to 1, y equals to 1 is here. So you draw your asymptote. Okay, so I have my asymptotes, I have my holes. What else do I need? I need a few more points, and I do have 2 points. That's going to help me graph. My x-intercept is at 2, 0. So 1, 2. So this is 1 point. And then 0, negative 2 over 0. My y-intercept is, so let's say 1 is here. So negative 2/3 is less. So this is here. Okay, so now I have to draw the wings. Remember we spoke about this? And basically the vertical asymptote divides the graph into 2 sections. So I need a wing on this section, I need a wing on this section of the asymptote. So this side, I can already see the x-intercept and y-intercept. So there will be a wing on this quadrant, this particular section. So what do? You connect the 2 points that are part of the graph, and on one side you hug the asymptote here, and on this side you hug the asymptote on this, and we are good to go for this side. What about on this side of the asymptote? You need 1 point to decide, am I going to draw it here or am I going to draw it here? So the fact that there is a hole is always part of the graph. So you work around the hole. So you draw this. So the graph will go through the hole. So basically on this side you hug the asymptote. On this side you hug the asymptote. So you have a graph, except the hole will not accept. And there is my rational graph. So I use vertical asymptote, horizontal asymptote, hole, x-intercept, y-intercept, and then if there are points already existing for me to decide where I need to draw my wings, I use those points. In this case I did, but not all your graphs will have. You'll have to actually start calculating, and you'll see that in some of the other graphs that we'll do. And this helped me finish the graph. Okay, but there's one last section, the limits. Let's finish the limits. So remember how you read the limit. As x is going towards infinity, you're reading the graph, but you're reading the y value. So as x is going towards infinity, so what's happening on the y part? So it is increasing, but it is it's tapering off at y equals to 1. This is y equals to 1. It's tapering off at y equals to 1. So it's limiting at, what is the value of y? Remember, you're always reading the y for the limit, because it's r of x. That's why. As x is going towards negative infinity, okay, where's my graph? Which part of my graph is going towards negative infinity? It's this part of the graph. And what's happening to my y value? So it looks like it's dropping down, but again getting limited at 1. So this will also be 1. Okay, let's read the other 2 limits. This limit says as x is going towards negative 3 from the positive side. Can you all see that? Negative 3 from the positive side. This is my graph. You're getting closer and closer to negative 3, but you're dropping down. That means it's negative infinity. Negative 3 from the negative side. Negative 3 from the negative side. So you're approaching negative 3. Which part of you want to be looking at this? Because this is the one that's approaching negative 3, but it's going up, 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 so it's positive infinity. Yeah, and the last one says as x is approaching negative 3, but it doesn't tell you from the positive side or negative side. So you look at the values from the positive side and negative side. If they are different, you say it does not exist. This is going back to your unit 1, where if both of them are different, you say it does not exist. So this ends page 25.